Back for another short video about the Gren programming language. Last time what did we do last time? We made a program that showed a number in the browser window with buttons to make it go up or down. Today I want to talk about Gren's type system. So Gren is a statically typed language. It will enforce that you are using values correctly according to their type, that you're passing the correct value to the function as it expects. But if you notice, we didn't specify any types here. We didn't specify the types of our functions or our variables or anything like that. Gren just inferred it for us, which is great. But your life will be improved if you explicitly type out your type annotations. It might seem cumbersome, but in the long run, it's very helpful for a number of reasons. For me personally, once you start getting very used to Gren's type system, you start thinking in terms of the types and designing things in terms of the types, and it just helps you think through a problem when sometimes you're writing a function and you just write out the type and write a to-do in the body of the function and get to it. But more practically, it will help with things like better error messages, better documentation. When you come back and you're looking at something, you can know that a function is being used correctly, as opposed to, is the function wrong, or how am I calling it wrong? So things like that is a little more practically why it's better to write out your type annotation. So I want to show you how to do that. In Gren, a type annotation looks like this. It's the name followed by a colon followed by the type of the value. In this case, it's returning. There are no parameters here, so it's just returning a value. So we have an init that returns an int. As easy as that. Let me pull up the compiler again, like I did last time. I used enter to compile every time I changed my file. So let me just make sure I'm not breaking anything as we go. Okay, still compile, still good. So we have, you know what? I noticed last time our model, we weren't actually specifying this type anywhere. So it was purely for show here that we had a type alias of model, but now we're actually going to use it. Here we go, look. Update. That takes an instance of our message type. It also takes an instance of our model type. This arrow syntax, I'll explain that another time. And it returns a new instance of our model. This may look strange. There's no delineation between the parameters that a function takes and what it's returning. I'm going to do a whole other video on that. For now, just bear with me and understand that you have you have the function name, and then you have the parameters, and then the last parameter in that list is going to be the return value. So still compiling. Our view takes a model, and it returns another thing. I'm going to ask you to bear with me. This single type made up of two separate types, HTML message. Just know that it's an HTML value, and those all hold a message type in them. And I didn't import the HTML type, so I'm going to do that. It's going to exposing HTML. This might also look strange. The HTML type, so we have the HTML module, and then within the HTML module we have the HTML type. So that's what it looks like. What I'm doing is I'm exposing this HTML type so that I don't have to type HTML.html. And then Gren is smart enough to figure out, when we're referring to the module versus the type. Wow, I really need to fix the fact that you can't see the character under my cursor. I don't know why I'm only just now realizing that that's happening. Something broke. I'll fix it. The main, again, bear with me. It's strange. You don't have to worry too much about this type, but if we're going to be completionists here, we're going to write it, and it's going to look like this. It's going to be program, an empty record, and then, I can't remember if it's model message or message model. And here's another helpful thing with Gren. Sometimes if I can't remember something, all I have to do is compile, and it'll tell me. And there it goes. It said it's producing int message, but it wants message model. Well, it says the type says it should be message model, which means I know that this is right. It's returning the thing I want, so I'm going to fix the type. And remember, we aliased model as int. That's why that first part there says int. Now it should compile. All good. We have our types. Before we go, I want to show one thing. So I mentioned you'll get better error messages. So let's pretend that I don't have not pretend, let's do it. Let's get rid of the type annotation for init. We're still good here, but let's pretend it's a little more complicated. Instead of just being a hard-coded value, it's going to accept a value. And so I'm now have to pass in what I want to initialize my model to. So this should be no change to the system, but let's say instead of an int, let's say I passed in a string. Okay, we expect that to fail, but look at the error message. It's pointing at my update function. It's saying, you know, that this argument is a model. Whatever. I'm not going to get into it. It's looking like there's a problem with our update function. It's very confusing. Now, when really the problem's here. But Gren it can only figure out there's a problem once it gets to the point where it's actually using those values in a way that it recognizes as wrong. And it hasn't recognized it's wrong here because it's not breaking any rules yet. You know, this is what we told it. It just returns whatever's passed in. It's an identity function, basically. But let's help Gren. Let's tell it, no, this is going to take an int and return an int, always. Now look at my error message. Okay, well, now it's showing me exactly what the problem is. I'm passing a string when I should be passing an int. I fix that, and we're all good. All right, next time maybe I'll get into this error syntax stuff. We'll see. Thank you. Goodbye.